Okay, now what is a transpose of a matrix? If the matrix A, if I know a matrix A, the matrix A is given by, let's say, A, B, C, D. You know the order of this matrix is 2 by 2. So there are two rows and there are two columns, row 1 and row 2. Then if I want to find the A transpose is written as AT, where T represent it's a transpose. Yeah. You convert the rows in the column. So this AB, you write it down as AB. Yeah. And this CD, you write it like CD. Yeah. So you convert the rows into column. If you transpose the matrix twice, now I want to transpose it again. So if I want to transpose that one again, now let's say I want to do A transpose of A transpose, it will give me AC. I need to write the A and C. This AC will be written as that, and then BD. BD will be written as BD. Yeah. Okay, which is equal to the matrix A. So if you transpose the matrix twice, the answer is the original matrix. Okay, now this is a system of 2 by 2. It's two variables involved and there are two equations. So we call them 2 by 2. If there are three equations involved, three variables involved, we need three equations to solve. How are we going to write in the matrices form? To start with, we cannot write that in straight away in the matrices form. First, we need to make sure all that they are proper. This is x, this is y. No, we can't write it that one. So first we write it down properly. So I can write down 3x minus 5y is 4. Then I need to write down minus 7x plus 2y equal 19. Minus 19, I mean. Now, once you got that thing, you need to convert into matrix. How we convert into matrix? We just draw these boxes here. 3 minus 7. So I got 3. 3 minus 7 from here. 3 minus 7 from here. Minus 5 minus 5. 2. I got that one there as well. Now after that one, I do this bit. I do x is the first variable and I do y as a second variable. Yeah. And then I do that. The last thing that's left should be red. It is not red. 4 minus 19. Happy with that? Then I'm just going to call them names. I'm just going to name them. I will say this is my A, this is my X, and this is my B. Yeah, A times X equals B. Now I want to find the value of the X. How should I do that? If I want to find the value of the X, X is equal A inverse B. Why A inverse? When I take the A from here on that side, it becomes A inverse. You cannot write B times A inverse because we know the matrices when you multiply, A times B is not equal to B times A. Matrices multiplication is not commutative. So you will have different answer. Now, I know what B is. B is this, easy. But I don't know how to find out the A inverse. That's a different thing. So let's find out the A inverse and we see how we are able to find the A inverse. Yeah? Now the A inverse has a formula. A inverse has a formula. A inverse has a formula. The formula is 1 over A determinant multiplied by adjoint of A. What is that thing then? You know what you know about determinant, but what is that thing? this bit. So let's find the determinant first. So A determinant, we have the matrix A always. This is the first step. We find the A determinant. 3 minus 7, 5. So I got 3 minus 7 minus 5, 2. So can you please find me this A determinant so we can sort this thing out? Then we look at that. So we said when we find the A determinant, we start from the right side, this multiplied together. 3 times 2 is 6. Then the minus of the formula. Then this times that. Minus 7 times minus 5 is minus 30, no, positive 35. Yeah. So that's that one. And the A determinant is minus 29. And it's non-singular. So we can solve the question. Yeah. So solution exists. Okay. We know the matrix. Um, we know the matrix A is this. Now, when we find the adjoint of A for 2 by 2, it's a lot simple. It's still a matrix. First thing, you swap these ones. So what you do is you swap these two. So what will happen is that will become a 2. That will become a 2 here and 3 there. Yeah. The next thing you will do is you change the sign of these ones. Whatever the sign, you change it. It is minus 5, so make it 5. It is minus 7, make it 7. If that was a 7, I have to do it minus 7. We change the sign. So these two change sign. These one swap. Yeah, happy with that? Now that's give you the adjoint of A. So we got that one. Now, once we got this bit, we need to go back and put in our this formula. So now we go back and put in this formula. So to find the inverse, let's say, actually I do in there maybe much better. So I need to find the A inverse is 1 over A determinant times adjoint of A. Yeah, okay. Now, what was the value of the determinant? We calculated it was 29, actually minus 29. And we have this value already, which is here 2573, 2573, 2573. Now we need to multiply 29 inside. Yeah. How do you multiply 29 inside? Easy. It's 1 over minus 29. So the way you do it is this. You just do that. You write 2 over minus 29. Don't need to solve it. Yeah. 5 over minus 29. 7 over minus 29. 3 over minus 29. That's give you A inverse. This is your A inverse. If you like, you can convert into decimals. Yeah. But if you leave it in fraction, you will get exact answer. Now, my question was not to find the A inverse. My question was to find, if you go back to the previous slide somewhere here, my question was to find the x, this x. So this is what I'm trying to find. But I got the A inverse and I also know the B. So I will go write this equation. I put the values. So in this equation, now this is my master equation. So now I got x, let's change a different color, black. X equals A inverse B. Now A inverse I copy from here, 2 over minus 29, 7 over minus 29. You can convert in decimal if you want. And what's the value of my B? B is given. B is 4 minus 19, isn't it? So B is 4, 19, 4 minus 19. Once I got this one, I need to multiply. Now you know how to multiply the matrix. It's a row times a column. So when you multiply them, it's always this bit multiplied by that bit. Yeah. First we find out, can we multiply them? So what's the order of this matrix? Order of this matrix is 2 cross 2. 2 rows and 2 columns. Order of this matrix is 2 rows, 1 column. Because they are same, we can multiply. And the order of resulting is going to be 2, 1, 2, 1. So I kind of already know how my matrix is going to look like. So it's going to look like that. So 2 over 29. So I do 2 over minus 29 multiplied by 4 plus 5 over minus 29, 5 over minus 29 multiplied by minus 19. I will put that in my calculator to get an answer. Now the next part, the bottom one, minus 7 over minus 29, which is that part multiplied by 4, yeah, plus 3 over minus 29 multiplied by minus 19. And I put these one in my calculator and I will have two values. Okay, this is not minus 7, it's 7. Thank you. Yeah, because that's 7 over minus 29. Yeah. So when you put that one, you get this value. Now what is x? X was actually an x and the y, because that x is, there was an x and the y, which mean the x is 3 and the y is, x is 3 and the y is 1. So I want to check my answer. To check the answer, if your answer is right, you go back in the real question, the first one, which is here. Yeah, you put the value of the x and you put the value of the y in this one. So you should get an answer 4. Yeah. So x is 3 and y is 1. So 3 times 3 minus 5 times 1. Yeah, the answer is 4. Yeah. And if you put that one in this equation, you will get answer minus 90. It should satisfy both equations. This is how we deal the 2 by 2 matrices. Okay, these other ways of solving this one, but we are going to learn the matrix way. So I want you to solve this one, form a matrix equation, and then solve that one. After you've done this one, I would like you to carry on with this question. With this question, you have to first find an equation. I will help you do the equation and then you can solve the matrix. A museum sell adult tickets and child tickets. So I'm just going to call adult ticket as A. Let's call it A, and child ticket as C. So Fozia buy 4 adult tickets plus a 1 child ticket. That cost £120. Sammy buy 5 adult tickets plus 3 child tickets, and that costs £171. Now you got an equation. Now you can convert that equation into the matrices and you can find the price of 1 adult ticket and 1 child ticket, A and C.